Section 4.4 is the first section where we solve equations by adding or subtracting. So our standard, this is one of our big ones, it's being able to solve equations. In the first bulleted point, you can see where it's a coefficient times a variable plus a constant equal to another constant. So P, Q, and R are all rational numbers. The second bullet point deals with distributive property, and then also representing and solving real-world problems using equations. So that's basically how we're going to spend the remainder of this unit. So several definitions today. The first definition is an equation, and an equation is a mathematical sentence that contains an equal sign, and it shows that two expressions are equal. The solution to an equation is a value for the variable that makes the equation true. We will do lots of checking our answers when we first start solving equations. So we'll use that solution to see if it made the equation true. We also have solving an equation, and that's just simply the process of finding a solution, which is what we will go through the steps today. Inverse operations, it's important that you understand that inverse operations are operations that undo one another. So addition and subtraction, those are inverse operations, and also multiplication and division are inverse. If I add 7 to a number and then I subtract 7 from a number, I should be right where I started. Similar with multiplication and division. Finally, equivalent equations, and those are equations that have the same solution. So the first property is the addition property of equality. We'll do addition and subtraction today. The addition property of equality states that if you add the same number to each side of an equation, the two sides will remain equal. And in the generalization here it says for any numbers a, b, and c, if a equals b, then you can add c to both sides and still have an equivalent or still have an equation. This does need to be written in your notes. And for the examples here, we have 4 equals 4. You would say that's a true statement. If we add 9 to both sides, so this says add the same number to each side, we're adding 9 to both sides, and I just picked 9, we get 13 equals 13. So the equation or the two sides remain equal. When we're solving an equation, you'll notice that what I've chosen to do here is add 5 to both sides, and what happens on the left side is that those two 5's cancel out, so you're left with y, and then 10 plus 5 is 15. And that is still true. So we're going to do some examples today, and we will be checking our solutions. So you need to make sure that you're doing that as you go through the solving. So when you look at an equation, you're always trying to undo what's being done to the variable. You're trying to get the variable by itself. So right now the variable has 7 being subtracted from it. So we want to do the opposite of subtracting 7. We want to add 7. And whenever you solve an equation, whatever you do on the left side, you have to do on the right side. So the negative 7, or subtracting 7 and adding 7, those cancel each other out, and you're left with x equals negative 4 plus 7 is 3. And now I'm asking you to check your solution. You do that by plugging 3 back into the original equation. So if I plug the 3 in for x, I have 3 minus 7, and I'm checking to see, does that equal negative 4? Well, 3 minus 7 is negative 4, so we get negative 4 equals negative 4, and that's true, so we know that our answer was correct. This is your answer. The work on the right, this is just your check. And until we are more comfortable with solving equations, we will always be checking our solution. There's actually no excuse to miss the answer on an equation because you can always check your answer. Number 2, we have 20 equals x minus 5. And don't be confused or thrown off. The variable can be on the right-hand side, and that's fine. So again, we want to look at what's happening to the variable. On the right-hand side, we have the variable x, and it has a 5 being subtracted from it. So again, the inverse operation of subtracting 5 is going to be adding 5. And we always want to do it to both sides. And I like to draw lines through my equation steps so that I can kind of keep things organized. The line through the middle, the vertical line, that's just to remind me to bring my equals sign down. And the line underneath my addition is just reminding me that I've got some things to clean up. So on the left, 20 plus 5 is 25. On the right, the minus 5 and the plus 5 cancel, and you're just left with x. So x equals 25. We want to check our solution, so we're going to rewrite the equation substituting in the 25 for x. And this is kind of like a question. You're asking yourself, is 20 equal to 25 minus 5? And if you simplify the right-hand side, you get that 20 equals 20. So I'm just kind of checking off that my answer is correct. Next we have y minus 6.4 equals 10.7. Again, don't be thrown off by decimals or fractions. These are rational numbers, and you need to be able to compute and solve equations fluently, even if there are fractions or decimals. So here we see the variable 6.4 being subtracted from it, so we're going to add 6.4 to both sides. Adding 6.4 on the left side will cancel out with the subtraction of 6.4 and leave us with y equals. We have 10.7 plus 6.4, and when we add that we get 17.1. So now we want to check our solution. 17.1, plugging that in for the variable, minus 6.4, does that equal 10.7? So we're asking this question. 17.1 minus 6.4, does that equal 10.7? Remember, we are allowed the use of calculators at this point. So in your calculator, 17.1 minus 6.4, and it does give you 10.7. So 10.7 does equal 10.7. Our answer, or our solution to the equation, is correct. Next we have the subtraction property of equality, and again this one also needs to be written in your notes, but the subtraction property of equality states that if you subtract the same number from each side of an equation, the two sides will remain equal. So similar to addition, but now it's just subtraction. So if we have a equals b and we subtract c from both sides, we'll still end up with a true equation. So in the example on the left, I have 7 equals 7. That's just a number I just picked. If we subtract 3 from both sides, again I just randomly picked to subtract 3 from both sides, we get 4 equals 4. That's still true. So the first equation is true. Subtracting the same thing from both sides, the second equation remains true. On the right we have an equation n plus 4 equals 9. So the opposite of adding 4, we're going to subtract 4 from both sides, and that's going to give us n equals 5. 9 minus 4 is 5, so then we're stating that because we subtracted the same thing from both sides, as long as it's done accurately, we still end up with a true equation. So let's solve a few more now using the subtraction property of equality. So now we see addition of 10. The opposite of adding 10 is going to be subtracting 10. Remember, we're always trying to isolate the variable. That's why we're subtracting the 10 and not the 23. We want the y to be by itself, which means we need to undo adding 10. So here we get 13 equals y. We're going to check our solution by plugging 13 back in for the variable. So that's 23 equals 13 plus 10. I'm asking if this is true. So we get 23 equals 23. This is true, so my solution is correct. If at any point you want to try to solve these on your own, you're more than welcome to pause the video and try that. Number 5, we have n plus 6.7 equals 3.4. So again, isolating the variable means we need to undo addition of 6.7, so we're going to subtract 6.7 from both sides. That's the opposite of addition, subtraction. So crossing out the plus 6.7 minus 6.7, that just leaves us with this variable m. Now we do 3.4 minus 6.7, and we get negative 3.3. We want to check our solution. Plugging negative 3.3 in for m, adding it to 6.7, does that equal 3.4? So then you can do negative 3.3 in your calculator plus 6.7, and you get 3.4 equals 3.4. Our solution is correct. In class, we'll work on worksheet 4.4.